Choosing an appropriate distribution. Introduction. A distribution is a statistical concept used in data research. Statisticians seeking to identify the outcomes and probabilities of a particular study will chart measurable data points from a data set, resulting in a probability distribution diagram. Statisticians can identify the development of either a discrete or a continuous distribution by the nature of the outcomes to be measured. Discrete distributions have a finite number of outcomes. The most common discrete probability distributions include the Bernoulli, the binomial, and the Poisson. On the other hand, if a random variable is a continuous variable, its probability distribution is called a continuous probability distribution. A continuous probability distribution differs from a discrete probability distribution in several ways. The probability that a continuous random variable will assume a particular value is 0. As a result, a continuous probability distribution cannot be expressed in tabular form. Instead, an equation or formula is used to describe a continuous probability distribution. The equation used to describe a continuous probability distribution is called a probability density function, or PDF. All probability density functions satisfy the following conditions. The random variable y is a function of x. The value of y is greater than or equal to 0 for all values of x. The total area under the curve of the function is equal to 1. In practical terms, we measure physical phenomena most of the time with continuous distributions. Variables such as time, costs, prices in project management and finance are typically continuous ones. Physical properties such as strength, power, volume, weight are also typically measured continuously. Atmospheric variables such as precipitation, flows, tide levels are also measured likewise. Some of the most common continuous probability distributions include the normal, log normal, PERT, triangular, uniform, exponential, gamma, and beta. As opposed to continuous distributions, there are also discrete distributions. A discrete distribution is a statistical distribution that shows the probabilities of outcomes with finite values. Statistical distributions can be either discrete or continuous. A continuous distribution is built from outcomes that potentially have infinite measurable values. Overall, the concepts of discrete and continuous probability distributions and the random variables they describe are the underpinnings of probability theory and statistical analysis. On At-Risk's version 8, there's an array of 97 continuous and discrete distribution functions to choose from, including 48 alternate distribution functions, ascending and descending. We will come back to the concept of alternate distributions later on. Also, there are 10 discrete distribution functions to choose from the palette. There is also a collection of 3 additional special distributions. Therefore, At-Risk makes available 97 distribution functions. As we will soon see on this course, the possibilities are endless because you can also create your own distribution functions with some creativity without necessarily requiring a degree as a statistician. In this training module, we present an algorithm developed as a decision tree that will show us how to make an adequate selection of an appropriate distribution. We accompany each decision using single at-risk examples.